Hi gang, real quickly I wanted to review with you how to calculate the APY or the EAR. So here's a problem I pulled from the end of your PowerPoint slides. It says the First Federal Bank has advertised one of its loan offerings as follows. We will lend you $100,000 for up to 5 years at an APR of 9.5%, interest compounded monthly. As you know by now, the APR does not take into account that we're compounding this monthly, which is why if we calculate the APY we will get a different rate. So let's go ahead and see if we can calculate what the APY would be based on that information. So we've got the formula up here. We're just going to come up, go ahead and hit our equal sign, put a parentheses just like we see here. We're going to do a 1 plus, but we're going to add an extra set of parentheses around the division here to make sure that Excel knows to calculate that first before it adds it to 1. So the APR was 9.5%. I enter mine as 0.095 divided by the number of compounding periods, which is monthly, which would be 12 months in a year, end parentheses. And then we can go ahead and end the parentheses there. The next part is to take that to the M exponent, which is a shift 6 key. That little caret is right above the 6 key on your keyboard, so you hit the shift key and then 6. And then M, the number of compounding periods is 12, subtract the 1, and you can hit enter. We'll get to the effective annual rate at 9.9248%. Then it says if you borrow $100,000 for 1 year and pay it off in one lump sum, at the end of the year, how much interest will you have paid and what is the bank's APY? Well, we already know what the APY is going to be. Let's go ahead and calculate the payment. We'll do this simple time value of money calculation using the same variables we've been using. So the future value will be 0. We're going to pay that off after 1 year. Present value is $100,000. The number of years, they're going to pay it off after 1 year, so that will be 1. Interest rate, let's go ahead and steal this APY or EAR that we just calculated. And we'll calculate the payment. Come up to your functions, go to financial, scroll down to payment, and plug in what we know. The rate, we'll grab it. Number of periods, we'll grab that. Present value was 100,000, future value 0. Hit enter. Oops, that shouldn't be a percentage. Let's go ahead and take that back down to a number. And we get $109,924.75. So the amount of interest that we would have paid is the difference between what we're paying and what we actually collected from the bank here, which was $100,000. $9,924.76 in interest that we would have paid. Let's go ahead and do another problem. It says if First Federal offers to structure the $9,500,000 one-year loan on a monthly payment basis, which is more normal, let's calculate the monthly payment and figure out the amount of interest paid. So we'll do the same thing that we just did. We'll set up a little chart here with our variables for time value of money. Present value is going to be $100,000. Future value will be 0. Number of payments here will be 12 because we're going to be doing this monthly. The interest rate was 9.5%. Excuse me, I've got to put the equals in there. Divided by 12 because we're going to be paying that annual rate monthly. And then we can calculate the payment. So we will go formulas, financial, payment again, fill in what we know. Hit enter. That's a payment $8,768.35. We would have to pay that 12 times during the year. Oops. So if I multiply that payment amount by 12, I get $105,220 paid over the life of that loan. Go ahead and subtract what we received, which was $100,000. That means I would have paid $5,220.21 in interest. Next thing it asks is to calculate the EAR. So we'll go ahead and, now that we have that information, we can do just like we did before. 1 plus, let's put in parentheses the APY. Divided by 12. Caret 6. Minus 1. 9,925 per